Hello, my name is Ben Benson, and today we'll be covering the topic of superconductors from the A-level specification of A-level physics from the exam board AQA in 2018. So first of all, what is the definition of a superconductor? Well, a superconductor is a material that has negligible resistance at a very low temperature. The potential uses for this, for a material with negligible resistance at a very low temperature, is a battery. You have power cables, let's say that's pylon. You have power cables, and you have railways. So you have these are the potential uses. So in terms of the low temperature, let's do that. You have something called TC, which is your critical temperature, and it's the temperature at which, let's say it's 160, minus 160 degrees centigrade. It's the degree at which it loses its resistance, the very low temperature part. So anything above it, it'll keep its resistance. Anything below it, and at this level, it'll lose its resistance not completely, but almost to zero. Now, given this, why would this be useful in general? Well, given Ohm's law, V equals IR, if you have a resistance almost at zero, so you have 0.01 ohm, let's say, then as the resistance decreases, in order to maintain the same voltage that you put through the material, the current will increase if you decrease the resistance, which means more flow can go through the material. More flow of electrons or carrying charge can flow through the material without being disrupted and without losing energy through heat. So the resistance, so if you can imagine friction, that's how I like to imagine it. The more flow or current that you've got in a material, the more likely that the electrons are going to bump into each other, heat up, and there'll be more energy lost through heat. Now, given that we have an almost negligible resistance inside this material, that means that less energy is lost through its resistance or through the material, so that's why it's useful. So the problem is with having a TC so low, a critical temperature, is that it's quite difficult to start up and replicate, and it's obviously, you can tell it's going to be expensive to maintain these conditions, especially when it's outside uses, such as power lines and railways. But if we were to be able to replicate this in terms of power lines, let's say this is a train track, and you've got the train here. So they can use an electric field between the railway, between these 2 points, and a plate here, and the electric field will accelerate the plate, and because there's no resistance, the current can free flow as it likes, and it will thrust the train forward at high speeds with no resistance and no energy lost. It's almost like a levitating train, which is very advanced. That sounds like something from a sci-fi novel. So let me just remind myself. So we've explained the uses, the potential use if the TC wasn't so low, and we've explained why it's actually relevant to have a superconductor, because it uses up less energy overall. Now, obviously, because of these disadvantages or limitations from being able to use a superconductor or create one, it would be very beneficial to find out a way to increase this critical temperature so that it's less difficult and less expensive to recreate these conditions outside. So that's superconductors in a nutshell. I hope that you found this video useful, and thank you very much. Cheers.